Almost time. Sweet, 10 o'clock. 10 o'clock. Let us share the screen. Okay. Sharing. And I am recording, so jumping on that. Want to be ahead of you guys. Sharp. Got to be sharp in the morning. By now I'm on like 4 cups of coffee already, so I don't know why I'm not sharper. But cool. So we're going to cover some introduction to sorting algorithms. I know it's like a lot of algos, especially the divide between the people that truly embrace the algorithmic thinking and then those that, you know, would prefer to build out an Express server, right? And just kind of do that and build out a nice responsive website with colors and, you know, some aesthetics. So I know Matt kind of spoke to it yesterday. I'm just going to kind of just reemphasize this, and I'll save this. I'm just going to kind of be using this once again. I'll copy and paste everything into a file and push it up into a JS file. I just want to use this for now. Let me just get to our channel. I'll paste it. Okay. So that's the CodePen. I mean, they are using CodePens also, right? So they're doing it with the intention of a few things. And one of them is to do testing, which I know that might have thrown some people off. They see all this red over here and they're like, I don't understand. I don't know what's going on. So I just wanted to spend a moment just discussing when you see this kind of testing architecture, what that means. So you're not kind of like taken back and don't really know what to do. So before we jump into sorting, I'll just kind of describe what's happening with these CodePens and this code here, and then any additional code you see towards the end of the CodePen that they've put together. We have used testing in the past locally for students. We don't really get into testing. The cohorts that I've taught, we haven't really gone into like testing. There might have been like a one-off lecture. One instructor really loved testing, so they might have did it as an advanced thing later on. We do have mini lectures around where students work through like creating functions they can be tested upon. But a lot of them kind of get lost in what's happening here. So I just wanted to mention that don't touch it. I mean, that's what they're telling us. Do not touch. And what it is, what Mocha is and what Chai is. And maybe just start it off. Did anyone do any kind of research maybe and like, hey, what is this? I'm just curious, and maybe went online to find out what those two tools are. And I assumed that at 25 people, one person would have been like, hey, let me take a look. You know, I suppose between building a web server, unless people are talking and I don't hear you. Right? Can somebody talk? I just want to make sure. Somebody say, hey, Joe, we're here.
No,
there you go. There, my peoples. Talk to me, peoples. That's what I want to see. All right. So audio's working. Just your spirit is a little subdued. So if you didn't look into it, I just pulled up the site. I said Mocha, right? And I was like, all right, let me take a look at Mocha. And so this is Mocha. And Mocha is a rich featured JavaScript testing framework running on Node.js and in the browser, which is kind of what we're doing, running it in the browser. And so Mocha allows us to run tests. So Mocha tests are run. And then we use this tool to kind of structure the test. I'm just going to go back here and we see like Mocha here is being loaded. Mocha.setup, and then the question would be like, well, where is Mocha itself being imported, right? Because I don't see anything here. There's just an ID up here for Mocha. Where would it be? And you'd have to go into the little gear icon right here. So in a CodePen, instead of like going to script tags in the head or the body or link tags to import CSS, you do it all within the tool itself. It's just, once again, a tool made and designed for people that want to build out small things to demo functionality. This is not what you would use for production level code, but it definitely assists in creating some very dynamic, very interactive websites. And you can load the code in here. So, you know, they're loading some other pen. I don't know what's in that pen. Here's another pen. Can't really tell you what's in those pens. That may be these. Not really sure. But here's Mocha. Oh, I lost it. Here's the Mocha. And then here's the Chai. Okay. And then we also have something called Babel up here. And Babel is a preprocessor. Most of the time we're using that type of preprocessor to convert ES6 code into ES5 code because the browsers don't necessarily understand the ES6 code. Okay, and React does that a lot, and Babel is a huge tool out there to do that. Okay, it's like fat arrows aren't really understood by all the browsers, so we need code to convert it from a fat arrow to a full function with the function keyword and all of that construct. Okay, if you're ever interested in like Babel itself, Babel, is it Babel.js? I think it's Babel.js. Let me see. Yeah, this is Babel. And Babel, you can try it out and just test it. It'll open a pane with 2 windows, and in the Babel engine, you're able to type in ES6 code. This is ES6 code, and it converts it into ES5 code. Okay. So, and it even adds, remember how I don't really use the semicolons a lot? It's not something I go out of my way to do. And you can see like there's no semicolons here, and then there's semicolons here, right? So Babel's like, grab all the code, add semicolons, and then it just does the conversion. This is a looping construct, an array method, and it turns it into, it's using fat arrow here, and then it uses a function right here, okay? This is a new way of joining arrays, and this is the kind of old way, using cats on an empty array. So I'm not going to delve into that. I just want you to see that there's things like this, which is called the spread operator, which spreads an array open, but in ES5 that didn't exist, so we need to convert it. That's just what Babel is doing. So if you ever see something like this preprocessor running here, it's because there's code that needs to be transpiled into an older version of the code. That's really all that means. So don't like change it, don't play with it. Just know that that's what's happening. And then what is Chai, right? Because I said that's what Mocha is. What's Chai? Well, Chai is a behavioral testing development, testing. What is it again? I forgot. Test-driven development and behavior-driven development. So it is both a behavior-driven development and a test-driven development sort of assertion library for Node. Think of it as like, you know, we have Express, right? So we know we have Node, and we use Node, right? You've been using Node as the server and Express as the web server up to this point. And I've mentioned when I was teaching the Express lecture that there's other web server platforms out there. Express is not the only one. I think there's another one called Sails, and probably 3 or 4 other ones that if you looked into web servers for Node, you would come up with these, right? So we've chosen one. The one we've chosen in this instance, say, as Express, is kind of like Mocha. Mocha is what we've chosen to use as our kind of engine, right, to test. And then to create those tests, think about what you've been learning the last couple of days. What was the one technology that Matt kind of really introduced that you've been using for the last 2 days? What's the one thing? I mean, he's taught a bunch of stuff, but what's the one import that you've kind of made that's relevant to what you've been building out these days? Last 2 days. Express, and then what else? What is the templating engine?
EJS.
EJS, correct, right? And there's other templating engines. There's a templating engine called Pug. We could even import React as a templating engine. There's other engines. And so Chai becomes that kind of testing thing. So I'm just trying to give you a comparison for something that, you know, is tangible to something you've been working with. In this instance, think of Express as the Mocha and EJS as the Chai. If you ever hear it, that's what it represents as to what you understand thus far. We're not going to go into that. I'm just kind of bringing that up because you see all this and you're like, yeah, what the hell happened there? Well, why is that coming? And then if I run a test, right? So if I was to run this, it turns green all of a sudden, right? So I ran some code and it turned green, which means it worked, right? Something didn't work here. If I try to return array 1 and then ran the test, it should fail. Yeah, it fails. Array 1 is not defined. It kind of gives you a pointer that array 1 is not defined and where you should start to do. It tells you what it should do. So at times, this is really difficult to kind of go through because it's throwing all these errors at you. You're not really sure. How am I supposed to meet the expectation of the thing? You have to be able to like, kind of like look through this and see what it's trying to do. I'm not great at this stuff, so I was never that instructor that taught the Mocha and Chai lectures. But I'm going to jump into basic bubble and insertion sorting. So we'll just take a look at that. Once again, the material last night. What's the general overall feeling of the material watching the slides? By the way, we're also going to put together a Google form to kind of collect and elicit some of that feedback from everyone. So I was just curious, being that you're now going through, you went through at least 3 modules previously. Now you have 2 of these, which according to the time constraints, should have taken you 15 minutes for this one and 30 minutes for that. That's 45 minutes without you even trying to like attempt all the algorithms, right? Just watching it, kind of learning. So do you feel like you could take all that in within the time frame and on top of your homework? Is that something?
To be honest, Joe, I have a hard time just reading and then trying to apply it. I actually thoroughly enjoy when there's somebody like you that's taking the time to code with me and explain it as we're going along, or at the very least having that one lady on the video doing it and trying to give like the visualizations with like the cards. I think that kind of helped, honestly, but just sitting there and reading it, it's kind of a struggle for me. So I'm not really fond of this setup. Okay.
No, that's great feedback. Once again, it is brand new material, and we're introducing it across every metro that's doing the SEI program. So we're going to provide that feedback, and we're going to collect that later. And all of that feedback is going to be important to help in improving this. I'm personally not, I go through the material, right? You can see I've been kind of going through the material, hitting some of the other material as well. This is not the best way that I would learn either. I would prefer somebody kind of walk me through the algo and step-by-step it versus like, here's some general concepts. Now you figure it out, right? To me, my brain doesn't kind of work that way. What else? Who else we got? Anybody else?
I think my problem is the fact that we normally have a decently long homework assignment, whether it's, a setup or just, and then after lecture and everything. So it's like, you're already kind of overloaded. So then it's like, oh, okay, cool. You're going to do this. If you get your homework done at a reasonable hour, then it's like, now you're going to learn this whole new thing. So I think it's just a little overload, and then it's all reading. So it's like, great, my brain's fried.
Okay. No, that's also good feedback as well. Once again, I appreciate it. Yeah.
So for me, like the biggest problem with it so far has been that I feel like the CodePen problems that were given are stuff that I would like to spend a lot of time on to make sure that I can actually walk through each step.
Sure.
But I just don't feel like there's quite enough time to really delve into it. Like I can give it a go and feel okay about giving it a go, but I don't think that I have enough time to actually sit through and solve it.
Yeah. No, and I get it. I think these are really tough to get through anyway, just in general. These are hard. If somebody threw out some of these other sorting algorithms, like inside of divide and conquer, there's merge sort, and what's the other sort here? Quick sort. If somebody's like, figured out merge sort, figured out quick sort, do the bubble sort, I don't intuitively like, oh yeah, you want that, Once again, this isn't material. We did teach some of the sorting things throughout, like, we're going to just teach bubble sort. And so now you'll just do one bubble sort and that's it. Now you know sorting algorithms. But they wanted to raise the bar on that level. So I do get like doing it once or just looking at it and not having the time constraints really makes it kind of a daunting task to be given these slides, given the code pens, and just kind of like do it without ever really understanding what's happening or thorough comprehension of the material. And that's not the intent. Like, that's not the intent that I want to convey. Like, I don't want to give this stuff out knowing if I'm giving it out, no one's really like grasping it or struggling to understand it or don't have enough time to do it based on the homework, or when they do it, it's like my brain's fried. I can't really understand. What's the point? You know what I'm saying? So,
Joe.
Yeah, sure.
So one of the things that I do like about this is that we can work through it at our own pace and we can back up and go forward. And I have two good things. The other good thing is I do think they do a really nice job at drawing parallels with real life, like the cards or the car example with the gas mileage.
Sure.
I think the piece that's missing is what Christian was saying, was nobody's walking through the actual coding with us.
Sure.
And I think to myself, like, if we didn't do this in the morning, all I would have is a general concept, and I really wouldn't be getting to that application part.
Sure. No. Yeah, that's true. And they give them credit. It's always nice to be like, hey, these are some of the pros of it. They did do a great job putting together the material in regards to conveying what it is and the concepts and relating them to kind of real world things that you're doing. But they did kind of fall short with, here it is, here, and without you having the solution, right? Because it's not like they provide you for the solution. So without actually having the solution to compare things, it's hard to be like, how did I solve it? I mean, all that really takes is doing a Google search for bubble sort JavaScript, and you'll get the answer in like 2, maybe 3 different ways. Okay. And I'm going to share some of the articles that I did find just quickly. I was like, bubble sort, what is, so I'm just going to stress kind of what Matt said also, when it's, I almost find it kind of daunting to say it, knowing that they're giving the material, hoping you kind of learn it, but look, don't stress it. You have time to kind of internalize this, right? It's only week 5, right? Week 5, we still have a lot more weeks left for you to kind of walk through it. You always have the algorithms. You can always go back, try to, at times, when you can, make a decision every week, even to pick 1 algorithm or 2 algorithms to just kind of work through continuously throughout the day or the week. And I guarantee you, if you picked bubble sort today, when you went on a 10-minute break, you just kind of like wrote the code that I gave. And then we went to the lecture, you came back on another break, wrote the code line by line, just kind of asking yourself questions. After a few days of that, you would have the code. It's kind of the rote memory and then understand. I mean, that's how I grew up. You did it, you memorized, and then you understood it later. Now they teach things completely different. My son in school, they're teaching them how to understand math, not memorizing. Like they have like 4 different ways to solve an addition problem or a division problem. And I'm like, I don't even understand that. Like, I just know I memorized this thing divided by that is this thing. I didn't know that there was this whole esoteric philosophy behind it, but cool. So let's kind of jump into it. So don't stress it. Take your time learning it. It'll come in time, and pick the ones that you feel more comfortable with, as well as do research and see companies that you want to work for. How hard do they push these algos? Just prep yourself. If you're going front end, full front end, no one's going to be like, do merge sort for me. Can you merge sort? They're not going to ask you to do that. They will ask you to do some algorithmic thinking, maybe like, flattening an array, because that's recursion, right? And recursion is something that you're going to experience out there. But these basic sorting algorithms are already incorporated into other tools. Dot sort in JavaScript is incorporating one of these. I forgot which one, but it's incorporating one of them. I think merge sort, possibly. So you're never going to have to sort on your own. But understanding the logic, the higher level thinking of how to solve a problem is what they're trying to achieve here. So what I kind of pulled out of, just the basic sorting algorithms here, they do have, the lessons, right? So you can download the study guide. Here's the study guide, and it's just a PDF, and they give give you a summation of the facts, not like the tutorials, not the videos, but just kind of the facts. The one thing that I kind of wanted to just point out here is, things like the time complexity, the space complexity, this big O concept, as well as they do discuss the complexity of the sorting algorithms as they compare them to each other, okay? And then this is probably one of the first times that you saw space complexity. What is the space being used here by these algorithms to solve this, right? So let me see. Slide 10 is time complexity, 11. All right, so I'm going to go into this really quickly and go to that particular slide. I just want to show, maybe do a little review of slide 10, right? That's the time complexity. When we went through this, I think the things that we could just recall probably fairly easy is that is constant time, right? So the naming conventions is constant time. I'm sorry. This is constant time, right? Constant time, logarithmic time, linear time, and quadratic time, right? So those are the basic ones. I'm just going to go here and say that as we were doing that, we know that constant time is big O 1, right? Which means the thing just needs to run once. That's like a function that console logs hello, an object where you retrieve just a value from the thing, an array where you know the position and you can return the thing. That's constant time, right? Then just in performance, right, we have logarithmic, I hope I spelled that right. And then we have log n, right? Where this is where we're trying to cut the algorithm, not by half, but we know something about the thing we're looking for. There's a piece of information that facilitates us going through this thing, trying to split things in half so that I can use only what's left. I can rule out certain things. And because of that, I have a smaller set of things to work with. And the more that I do that, the log goes up only minor, right? If I have 3 elements, 10 elements, then it takes me 3 guesses, right, to play that guessing game. If I have 40 elements, it takes 5 guesses, 86 guesses. You can go to a party, next party you go, hey, I bet you I can give you a number from 1 to 600, and I could guess it in less than 10 guesses, provided I get to ask 1 question and see if you have any takers, right? I'm sure somebody would be like, all right, and all of a sudden you're going to be able to show them something. And then we had linear time, which means I have to touch everything. Every element in the array needs to be touched, evaluated, even if I did not need to say evaluated at the time. I still need to touch it. And that's, once again, there is the best case and worst case scenario. And what is Big O looking for? Big O is looking for which case? The best case or the worst case?
Worst case.
Worst case scenario. That's what it's looking for. Worst case scenario. Okay, that's what we're basing all this on. And then for quadratic, right here, right? Quadratic means we have, what does quadratic insinuate? What does quadratic really, in the end, insinuate? What's happening? Go ahead, I'm sorry.
2 loops?
Yeah, 2 loops, right? It's a nested loop. Right? O and right? So this is really what encompasses this is nested loops. That's what that's doing. Okay. This here would be looping over an array once. Nested loops means I'm looping over an array possibly twice, right? This is something about knowing something about what you're looking for, right? And being able to use that, okay? And constant's just, returning a function or executing a function, right? Getting a key, a value from an object. Something as basic as that, right? So obviously you're always pushing for these two here, like those are the two things that you're always pushing for. If you have to go into the world of quadratic, you do, but just know that now you've hit some sort of performance hit, at least for complexity, time complexity. And time is not the time it takes necessarily, but the amount of steps needed to do the thing, okay? And then when we get to space complexity, well, once again, space now measures the amount of memory needed for this. You know what I'm going to do? I'm just going to go get my adapter again. I keep forgetting to bring it. I'm on 27%. All right, I'm back. Saved. So when we're talking memory space, right, I have all these things and I'm loading them into some sort of spatial memory to be used. And so they kind of make a point here that there's in-place and out-of-place memory. And so something that's using O1 or log n, the space algorithm takes, the space it takes is predictable. It does not depend on the size of the input, right? But when it's out of place, the algorithm uses an extra array or more into which to store those values. So think about you creating an array or passing an array, and that array needs to be stored someplace. And the concept of actually storing things is, in programming, there's something called a heap and a stack. I showed you the stack yesterday, right? We went into developer tools and you saw that the stack was where functions were kind of being layered on top of one another, right? So with the stack, we had functions being loaded, but the heap itself, right? So the heap stores objects, right? So the heap space contains all objects created, but the stack contains a reference to those objects, okay? So when we create variables, we're storing them kind of in the stack. But if we create objects and arrays, they're being put into the heap itself, okay? And the heap can be accessed throughout the application, okay? And primitive local variables are only access the stack memory blocks that contain their methods, okay? So there is this concept of like a stack and a heap. Just know, once again, from what you've seen thus far, that a stack is where functions are being loaded, right? One on top of each other, and when in recursion, when we get to the last function, we then come down the stack. The stack is last in, first out concept, right? And that's why when we hit the last function, we returned down this kind of pile of functions, okay? Now, I don't want to get too far into that, but once again, you can read up on it. I personally don't think no one's ever going to ask you about stack and heaps. I've never heard any students. I've been on several interviews. No one's ever asked me about stacks and heaps, so it's not a concept. You're going to have to know, just kind of throwing it out there, because you did see the stack the other day, okay? So, so the more arrays we load, we have to store that somewhere in the heap, right? An array is an object. So more heap memory we'd need versus more kind of stack reference to that memory, right? And then they kind of show us I'm just gonna get to the best and worst case sheet for these algorithms, right? So, and then they kind of go through some Greek lettering. Once again, I'm not that familiar with the Greek lettering. No one's ever going to ask you for that, so I can't really speak to it. But they're talking about bubble sort, insertion sort, all of these sorting algorithms. You will not have to know those. If anything, you might be just, maybe somebody might ask you to like code a bubble sort, if they do. You know, I can't imagine them going like, give me merge sort. Maybe you'll speak to it and say merge sort does this, but I can't write that thing. I'd be hard pressed to kind of go through all these things too. That would take me a while. And they just kind of give you like the average case, the worst case, the space that it's using here, right? Space is what it's using. So bubble sort is only using linear or constant space because we're using the same array. We mutate the same array. So it's just one array. We didn't create a second array to do anything. okay? And then we start to create additional arrays, I suppose, over here with merge sort, right? The number of elements looks like we might just have an array for each element that we actually get. Create a separate array with merge sort, okay? Once again, I don't want to delve too far into that. Not something you're going to have to worry about. You're more interested in just kind of working through the bubble sort. Okay, so I wanted to work through the bubble sort. I wanted to use their kind of logic that they provided here to see if, you know, here's the solution. I'm going to kind of work through the solution. We're going to code it out. I just want to show you there's the solution here, right, or one of the solutions. So when we're doing bubble sort, and there's a few ways to do, at least 2 different ways to do bubble sort. I'm going to start with one kind of solution, all right? And then we'll do a double nested loop so you can see what's happening, like why this thing is a quadratic solution. So it says make some sort of loop that keeps happening if there are swaps that happened in turn. So what I want to do is this. I kind of want to just, I'm going to do it the way I think they want you to do it is this other way where you're going to be using a do while loop, but that's not something that we've done to this point. So I'm going to just take those instructions. I'm going to just kind of put them down here for now. Okay. I'll walk you through it and then I'll go back and explain the more efficient way. So I'm going to do this. I want to grab the length of the input array, right? So length is equal to array.length. Okay. The reason why I'm grabbing the length of something is why. If you know we're doing looping here with for loops, what's the intent of grabbing the length and storing it here? And if I'm doing it twice, right? Nested loops, what's the efficiency here of putting array.length within a variable called len? I just mentioned I'm going to be running a nested for loop. And for loops require a condition. And most of the time when you're looping over, I see Josh like shaking his head. So Josh, you tell me. Tell me why.
Well, if you're nesting another loop inside a loop, you're
Yep.
going to want it offset by 1. So you can do let len equals array.length, and then you'll have the actual length of the first one. Then you can do like +1 for the other one, or -1, and then
Okay.
it'll loop next to it.
Okay.
No?
No, that's not where I was going, but I'd like I like to try, right? Let's think this through. If I do a for loop now, once again, this was just an efficiency measure. You didn't have to do that, but just say I'm using length. I'm going to say for let I is equal to 0. That's how we usually do the initial for loop, right? It's almost always I. I don't ever really see it anything else. While I is less than length, I'm already getting the efficiencies of kind of storing something in a variable, right? I didn't have to type array.length. I did this, I stored it in here, so this just makes it a bit more efficient. That's it. Not a lot going on there. And then I plus equals 1. I like to do, you're going to see plus plus a lot. I like to do the plus equals 1. I just think, once again, it's more intuitive for who's ever reading the code. Now that we're in this loop, I need to do a second loop, right? Now, the intent is this. We're going to be comparing each of these elements, and when we're doing that comparison, let me just see if I think I can annotate today. Let me see. Annotate. Do I have it? Did I not come up? There we go. Text. Let me see. Do I have it? Here we go. All right. Oh, cool. Can I? Not. Select. It's moving my mouse, but it's not drawing anything. All right. I'm not going to be able to annotate. I'm still trying to figure out why my annotation is not working. So I'm going to do a second for loop. And I'm going to do let j is equal to 0. And while j is less than length, once again, this is where that efficiency, that small efficiency I was talking about, right? Instead of copying and pasting length, typing it here, I just store it in length. That was one small efficiency. That's really the answer I was looking for. And then j plus equals 1, right? Okay, so there's my second nested for loop. Now the reason is because we have an array of numbers, and I need to compare the first number with the number next to it, and then the number next to it with the number next to that, and I need to keep track of the positions. Plus, I also, if I did have an array, right? So if I just said let r is equal to 1, 2, 4, 3, 2, 1, I have to make sure that I cycle through the array one full time at least, right? To make sure I get through all the numbers. I do all the comparison, and that's kind of what this is doing, right? This first for loop, make sure that you have cycled through the loop, the array, at least one solid time, okay? But doing it one solid time isn't enough because we might have bypassed a few numbers, swapped them, but now they still need to keep being swapped further back into position, right? Like this, if we just did one swap and we went through, then one, right? If we just did one swap, then the array would look something like this, right? 2 with 3, right? And then it would be 1 and 3, something like that, right? If we just went one way through, we wouldn't get all of the numbers where they need to be. So we need to do something in order to guarantee that we go through the loop at least once. And then when we do that once, we kind of go back to the beginning and just keep hitting all of those numbers again. We're on the second one, just keep hitting them, making sure. All right, so this second loop is needed for that. Now that we're in the second loop, right, we can start with a condition, right? So I'm going to start with this condition. Now I'm looking to see if the thing at a specific position, at array, and what am I looking at? I'm going to look at the element that has position j, okay? If it's greater than the array at position j plus 1, okay? If it is greater, then we're going to do a swap. And this particular swap that you're going to see is a standard way of kind of like randomizing things also. This method of swapping is also used if I wanted to randomize an array. It's just a standard swap. I think it's Dijkstrom method or something like that. And so what we're going to do is this. I'm going to say let temp, TMP, is equal to input. Array, right? Array j. So what I'm doing is I know I have to swap two things. I have an element here and an element here, and I need to swap them. So I'm just taking the element that needs to move further down, right? We need to kind of swap and giving it a place to kind of stay because I need to overwrite that thing, right? At some point in time, my array needs to kind of look like this. Temporarily, it's going to need to look like, so if I did do the 3, 2, 1, right? At some point in time, I need it to look like 1, 1 in order to do the swap, okay? I need to write them, and then if I had some variable here called temp is equal to 2, then I can go back here and then put 2 in later on. It's an afterthought. But there's going to be a point in time when both those positions are occupied by a same value. Like that's the instance. So I'm taking 2 and I'm kind of moving it into a temp position so that I can then do array j is equal to array j plus 1, okay? Let me see, did I hit my, okay, array plus 1. So now I'm getting the thing at that position, at 1, right? And I'm storing it, so I'm taking the 1 value and I'm kind of moving it over here, but I haven't touched this yet. This thing is still where it needs to be. I haven't moved it. I just took 2, right? Well, actually here, I took 2, I put it up here. So that would have been this instance here. I took the number 2, I moved it up here. I then take this value and I copy it over here. And now I have to assign this value to the number 2 to do a complete swap, okay? And so I would take array j plus 1 is equal to temp. And now I've done the full swap, okay? That's what's happening here. Okay, you take the first element that you know needs to be swapped with the element to the right of it, and you put it in a temp variable. So we can use it later on. Then you do the swap, right? So this performs the swap. That really does the swapping, okay? And then, you know, this resets the variable, okay? That's this. We put temp in so that we can give temp its new position, right? Actually, that doesn't sound as intuitive as I wanted it to say. But does that make sense what we're trying to do here? Kind of in a nutshell, going through the array one at a time, right? Comparing, say, 3 to 1, making a decision if that needs to be done. Okay, and if it does, then we do. This isn't the most efficient also. J should really be something like I plus 1. A more efficient way would be I plus 1, so I'm always 1 ahead. I don't want to go through the array multiple times starting at the beginning. If I touch the first number, I kind of want to keep going. But I'm going to leave it as is. So now we have this algorithm, and that should work. I don't know. Let me see. Let's see if this will pass our test. I don't know if it's going to pass the test. If this is what they really wanted, but does it? Doesn't pass the test. I know it works, but it's not passing our test right now. I think it's the other way that they want us to do this. But I was showing you one. Yeah.
Sorry. Your temps are not lining up the variable.
Oh,
names.
that's right. That's right. TMP, right? TMP. Got it. That was it. So maybe now it's going to, yeah, so now it works. Sweet. Awesome. I thought it really should work. So did it give me an error? Let me see. I didn't see any errors.
Yeah,
so.
it said your temp wasn't defined.
Oh, okay. Thanks, Molly. Yeah, I didn't see that. Thanks. Sweet. Okay. Wasn't even looking at the errors. I was just looking to see the red disappear to green, and when I didn't see it, I was like, maybe this test isn't gonna work. So I think the difference is too, the fact that I can run multiple solutions on this is because we're using in Chai, we're using this behavioral testing, behavioral driven test. Okay, right? BDD, behavioral development, right? Behavioral driven development. I always get it confused. And so it just wants the result. Is it sorted? You can do whatever you want as long as the thing is ultimately sorted. If you return a sorted array, you can sort it any way you want. And so this is one solution for that, right? And if we, look at the instructions here that they had given us, it's like make some sort of loop that keeps happening if there are any swaps that happen, all right? But then they also say reset swap happen to false each time so we can detect that swap. Now, I wanted to show you something more basic so that you can see, I think this is the most basic way of doing bubble sort. And as, kind of junior developers, people would normally kind of lean towards this, knowing that they have to do nested loops, knowing that you have to keep going through the array and doing the comparison. Yeah. To me, this seems the most intuitive way of doing it. Okay. Now, I'm going to take this. I'm just going to comment this out. We're going to do the other one. Okay. So I'm going to say function. Bubble.
Joe, real quickly.
Sure.
If we were tasked to do something like this on an interview, and if we did it this way versus the do while way, would that technically be wrong? As long as it accomplishes it, it doesn't necessarily have to be the most, unless they're specifically looking for the most efficient way, it should be fine, right?
Yeah, no, it's going to be fine. Once again, they're testing you. And in the end, Christian, as a developer, so we're talking as a developer, we're in a room, we're discussing how to implement something. If somebody did say bubble sort, right, and you knew that there were multiple ways of bubble sort that you could effectively solve right now in front of them, then I would bring that up as a topic to discuss. Because they're going to say, all right, so talk to me about bubble sort. How would you solve it? They're not going to just ask you to go to the whiteboard and solve it. A good interview is walk me through solving it. And then you could say, well, there's two different ways to solve bubble sort. One is using a nested for loop. It's a common way of doing it. I've done it before. When I have to shoot from the hip, I'll just do that. And then another way to do it is using a do while loop. I kind of like that one. I think it's more efficient. Right? And then they may follow up with questions. Well, why do you think it's more efficient? Right? The do while loop is more efficient. Let's just put it that way. This looping construct here needs to actually run through the loop as many times as there's things, right? And then multiple more times. Go through the loop one at a time, go through the sub loop, right? So we want it to be more efficient. And that's the conversation I would have with them. I would say, yeah, we could do it this way, or we could do it this way. There's, you know, multiple ways to do this. Okay. So I'm going to do it this other way using a do while loop, right? So this way, I'll just put a note here. This was using two for loops, using nested for loops. That's that iteration. Once again, coming from like general coding background, just 5 weeks in, that's an intuitive way of doing it. Now, what we want to do is create a looping construct here, right? So what we're going to do here is I'm going to do this. I'm going to do a loop. Now, I'm going to use a different kind of loop here, a loop that we're not normally using. You might have seen something like a do loop, a do while loop, okay? Do while, and what we want is if this is true, I'm just putting a condition in there just so that we understand. If that is true, keep doing this thing. That's it. As long as that thing is true, keep doing the thing, keep doing the thing, keep doing the thing, which means, what does that actually seem like is happening? If I ran this and I said console log, stop the madness. Why am I saying stop the madness? If we ran this, what happens here?
It's an infinite loop.
It's an infinite loop, right? While true, while a condition is always true, keep doing this. Well, if we don't put a mechanism in place to change something from true to false, we have no means of stopping. This is kind of our base case, right? When we come to recursion. So our base case would be to change something. So I'm going to say here, let swapped is equal to false. So in this original do loop, I'm setting a value equal to false, okay? And by doing that, this thing, if it's ever turned to false, I mean, it's false right now, and if I did this, what would be the return result here? Say we ran this function. What would happen? Can anybody just walk me through what would happen here?
So basically the do while loop, it will go through one time until it gets to that last on line 18, and then it evaluates the condition. So if it returns false, then it stops. It doesn't go through again. But if it is true, then it goes back up to the beginning curly bracket, and then it goes through again until while is false. Exactly.
That's exactly what happens, right? So when you do a do while loop, you're doing it with the intent that you want something to happen at least once, just once. I don't really want anything to be evaluated yet. I want to perform an action and then see if I need to perform that action again, right? Do it once, do some hey, let me update some variables in here. Then I'll ask while, hey, while, should I do this thing again? And while's like, I don't know, kind of based on what you did. Yeah, run it one more time. And then you keep doing it. So this could be an infinite loop if we don't, at any point in time, set this swapped to be false, okay? The fact that we're running it once is good, and then we're going to do this. So now we have to do this looking through our array of elements, right? So I'm going to say for let I is equal to 0, while I is less than array.length. Once again, I'm only going to use length once, so I don't really need to store it in a variable. It's not a double nested loop, so there's no efficiency here in creating a variable that stores length. We're going to do I is less than 1 here. I want to do less than 1, and then I plus plus, or plus equals 1. Okay. So I'm going to go here. Let's get into the for loop nuts and bolts here. Now, we're going to do the comparison between the two, right? So I'm at a certain location. So if array I, if the position that I'm at right now is greater than the element to the right of me, I plus 1, right next to me, then we're going to do something, right? What did I just do here? All right. We have to do something. That do something is the swapping. And I'm going to do the same thing. I'm going to do temp this time instead of TMP. I'm going to stick with TMP. Temp is equal to the current element, right? This element needs to get swapped. You put I. Okay. We need to store that in memory. because it's going to get overridden, then the array at that position that we just stored in memory, so we could retrieve it later, is now going to be turned into I plus 1. We just did the swap. So now I have two values that are identical sitting next to each other, right? There's two number 2s there, and now we have to get the number 1 that we stored up here, or the number, I'm sorry, two number 1s. We have to get the number 2 that we stored up here and put him back into the array. That's what we need to do. So I'm going to say array I plus 1 is equal to temp, TMP. Now we just did the swap. It's the same swap. The same logic that worked here is working here, okay? When you see something like this also, this may insinuate creating helper functions, a helper function that swaps elements in the array and returns the array back to you. That's also something that they may ask you on an interview. Hey, can you create a helper function that would take that? And like, we could use this thing elsewhere. I got lots of instances where array elements need to be swapped in position and then the array returned. So that's a pretty useful, reusable thing. I don't ever want to have to write this for the dozen or so applications that I'm working with, okay? So we have this. Now, here's the thing. We set swap to false because we wanted to kind of go through this and make a decision, should we continue looping through the array? So the truth is, the fact that we found one element that needed to be swapped, right, insinuates that other elements may need to be swapped. Until we go through one full iteration where all the elements are sorted and I don't have to do any swapping, then I need to set that variable, swapped is equal to true. I need to set that. That's important because this action right here, this condition, if the below condition is true, then it's possible other elements need to be swapped, right? It's quite possible that that needs to happen, and we need to go back to the beginning of the array and keep moving these things down in sequence until, right? Because if we did this once, and I was using that 3, 2, 1 array, we'd know that 3 still needs to be swapped, right? Or 2 needs to be swapped. So the fact that we did this, we set it to true, which means now that once this happens and we found an element, oh, an element needs to be swapped, cool, swap it to true. When we get to while's like, hey, what's the status of swapped? And it's like true, and he's like, all right, go back. We set this as our mechanism here to determine if we don't need to do any more swapping, okay? We set this as our mechanism to end the loop when no elements have been swapped. No elements are swapped, we've made it to the end of our loop, and then we're done. And the only thing left would be to return the array that was passed in. I'm going to say this. Just going to run it. Let's see. Should. Swapped is not defined. Did I not? Swapped. Did I misspell it?
I think you have to maybe take it out of the do while loop, maybe because of the scope.
No, we actually need, no. So this is a scope, but the issue is this: because it's scope, we didn't have access. Let is this. We've learned not to use vars, right? Vars are something that we've been told not to use. Have you been told? Matt's told you not to use vars. Are you using vars or are you using lets? Lets, right? Okay, lets are the new thing. Lets are the thing. Consts are the thing. Vars were an older way of doing it, and they had this kind of loose scoping. If I created it here, it was accessible to a greater degree than a let did. So in this instance, this let that's defined within this block isn't able to be seen inside of this if condition, which would have looked up to the for, which I thought would have had to look up to here and would have found it, but it did not find it. Christian was right, though. We could have moved this out at some point in time, but where it is right now is perfectly fine if we used a var. Okay? So I'm actually not sure. I don't know if we did move it out of scope. Let me just say, I'm just going to test. I don't really know. I'm going to be honest. Maybe by me doing let swap is equal to false. I don't think that that's going to work. No, that's not going to work, Christian. And the reason is this is because every time the do loop happens, we have to set this to false. Oh, we could have done this. Yeah, you're right. We could have done something like that, right? Could have done that.
That's exactly what I was actually thinking, because then that way it's available in the scope, but then you're still setting it every time you're going through back to false.
Correct. Yeah. So that works. But now that's more lines of code, right? So in a way, I guess just a more efficient way of doing it would have been to put the var here. So if swapped isn't needed anywhere else outside of here, in the rest of our code, say we had like hundreds of lines of codes here. If swapped wasn't really needed, then I wouldn't elevate it to a scope that it doesn't need to be referenced, right? Then I'm just kind of polluting the little, block scope here. So I would have limited it to where it needs to be. If I see it here, then I might make assumption when I see additional lines of code that aren't involved with this, that maybe swap needs to be used there too. Swap may need to be used, down here in like lines 50 to 100. You're making that assumption because of where it's located. Things that are located here more global to the actual code block, you're making an assumption that it's possibly needed to be used elsewhere or it needs to be there because of scoping. So we could leave it there, but you're going to tell them, here's a really good interview question, right? I would say, oh yeah, and then I have to use var here because of the scoping, and like you can talk about that. So that's also another good thing. Or if you did do let's, and they knew, oh, let's not going to work. When it doesn't work, you're like, oh yeah, here we go. This is why. Oh, I didn't, so excited to write the code, I forgot. Because of the scoping here, we can't use let. Let is block scope. It can't be seen here in these scopes below. So we need to kind of elevate its status or provide a greater degree of scope availability, right? If I heard that from a candidate, I'd be like, this guy's hired. Like it. So, how are we feeling with bubble sort? Still don't get it? Dad's like shaking his head. Like,
Hey, Joe, on line 27,
yeah.
Don't we need to define the while condition? Like,
so this is
What?
the condition right here. Swapped is either going to be true or false, right? Swap is false initially, right? Here, from the start, and is only changed to true if a swap occurred. Okay? So initially, when this thing is run, right? When the code runs, the do block kicks off immediately, right? It's the first thing in the code. So it sets it to false. It says, all right, I'm going to assume that the array does not need to be sorted. That's the assumption that this makes. Making an assumption that array is already sorted. That's what we're making here. And we're saying, all right, I'm just going to do that. I'm going to pretend like the array is sorted. Unless you prove me otherwise, we're just going to run this bad boy one time. It goes through the code, and it's like, whoa, I found something that needed to be swapped. And then we're like, oh, if you found one that needed to be swapped, maybe there's more that needed to be swapped. So I need to run this thing again one more time. Okay? And so we're going to run it one more time. But before we run it, when we do, we set it again to false, making the assumption that this second time, it's guaranteed to be like sorted until we hit this and we're like, oh, wait a second. You're still not sorted? All right, let's do it again. But I'm still going to kind of play the game like you're sorted, right? And we need to do this because if we don't ever set something to be false, then the while loop will just keep running forever for perpetual motion. Does that make sense?
Right, but don't we need to say like while swapped equals false?
Oh no, swapped is going to be true or false. So it's really being converted into a Boolean at this point in time. Okay?
No, I get that. I don't understand how we're exiting the loop.
Oh, because here, so what happens is this. The do loop happens one time, right? And then while asks the question, hey, is the thing that you're looking, the condition that you're looking, asking me to check, is that true or false? If the condition is true, rerun the do loop. If it's false, go to the next line of code. Okay? So originally, when do is run, swapped is set to false. Okay? And so we go through the code. If we never did this, then once we hit the while loop, swapped would be false. If the condition is false, then the loop ends, right? That's what a while loop does. The condition must be true for the loop to continue. And the loop is this. This is the looping construct. Do becomes the loop. So we need to set this to true to tell it, I want to rerun it. And if we set this to false, and this condition never happens, if that condition never is true and no elements ever were swapped, then the value of swapped is false, right? It's a Boolean false at this point. And while something is false, don't do it. Really, that's what it says. Whiles only say if it's true, do this thing, not if it's false. Okay? And it's the same thing for a for loop, right? This for loop only runs while j is less than length. While the condition is true, do the thing. The minute it's no longer true, we stop the loop. Does that help at all?
Yes, thanks.
Okay. Once again, I get we're seeing something new here too. We're seeing do while loops, which is something that you haven't really worked with. You've been working predominantly with for loops. So that's why I showed it, because I wanted you to have something tangible that you understand, and then throw something else out and you're like, shit, how am I supposed to work with that? Like, I never saw that thing, and now you're throwing this new do loop while thing, right? If anything, just go to W3 Schools and say, you know, do while loop. And, you know, I always like going to W3 Schools. Where is it? W3 Schools. No, that didn't come up. Do while loop JavaScript. Let me see. W3 Schools, right? While loop. If you go here, they'll walk you through here doing a do while loop, and they kind of walk you through what a do while loop is. Do they have any other loops? I think that's it for the do while loop. Yeah. So we opted to use that once again because I understood what we were trying to accomplish, and so we did just that. Cool. You know, it's a lot, right? It's like first thing in the morning, you're like, man, this is not what I signed up for. This is why people get paid a lot of money. This is, depending on which direction you go, the ability to do whatever the task is why people get paid a lot of money. Doing stuff like this, JavaScript engineering, takes a different mindset. Okay, you're building something. It's like somebody that wants to build a bridge. That's an engineering mindset. I don't really have that. I'd have to go through a lot of studying to be able to, you know, weights, capacities, and blocks and stone. Like, that's math. I don't know. Or not an astronomer. What's the other person that studies the stars and distances and things? I couldn't do that. I've seen some of those equations. My brain just cannot comprehend that stuff. It just doesn't. I spend the rest of my life trying to do something I'm not good at. But this stuff here, you can internalize at some point in time. I guarantee you can internalize this stuff and just do it at a most basic level. But always pursue the things that you're really interested in this industry, because that's where you'll get the most success. So if it's front end, go front end. If it's back end, go back end. If it's algorithmic thinking, run with algorithmic thinking, and you'll find a job as a JavaScript engineer constructing algorithms that solve problems.
Hey, Joe.
Sure.
Now that you say that, I'm curious on something. Is there any of, like, the couple things you just named, is there any that are in higher demand? Or is it all just like, you know, just kind of where you go?
I would say JavaScript engineers are going to demand a greater salary than a front-end developer, because it requires this mindset. You know, it's just.
Well, no, I mean like for companies that are out there looking for positions, like what are in higher demand? Or is it like front end? More people are doing.
I think at this point in time, I think possibly at this point in time, it may be, and I'm just going to keep throwing it out there, like back-end engineers, because a lot of the companies are building applications that require this logic thoroughly thought out. But also, as you know, I've seen UX grow from like 1 or 2 cohorts to like UX is a huge demand these days. Your application is only as successful as the way that people can work with it. If they cannot work with the application, then it's broken. That's it. So
I'll toss in my opinion. I'm just sort of catching up on this. I've seen front end grow tremendously over the last few years. The amount of you can tell by the amount of JavaScript that's out there that I suspect, like if you look at the numbers, the different like there's a good what is it? I'm blanking on this now that I'm on the spot. The developer survey from Stack Overflow.
Oh yeah, the Stack Overflow survey.
So that's a pretty good general overview of like the world. And JavaScript, I think, is the #1. And judging by, that now it could be that everybody who's doing JavaScript is doing backend, but I don't think that's the case. I think in all likelihood, it's mostly front end work that's doing JavaScript. See, so JavaScript is top right there, 67.8%. So now this is just given my experience, but we kind of saw it yesterday when I was looking for companies that do Node.js backends, because that's the only way to do backend work in JavaScript. And I had trouble finding them. There are some out there, and I got to find it. But I think the amount of Node work for backend compared to other languages like .NET, Java, is less. So I suspect that most of those 67.8% are probably doing front end. So I would say, I mean, given my experience, there's more front end work out there, and especially at the level where you guys are, it's more front end work. I think back end work, again, in my experience, it mostly goes to people with CS degrees. But that's just because that's just my experience. I could totally be wrong, and it's also New York City, and at least that's the metro that I know the most. So what I would suggest doing, you guys, this is a great thing to do, is go on LinkedIn, go on, I don't even know what the other sites are that do this, but just go online in your specific area, look up the kind. Google has one. Google has you can do like Google Jobs, and they'll also look for postings in your specific area. Because the downside to remote is that everybody's in a different area. So like Python might be really big in one area, PHP might be big in another, Ruby on Rails might be big in a third. So really, it's up to you to sort of figure out what the languages that are popular in your specific area are, and try to sort of hone your skills in that direction. And you'll see by the end of this class, you'll be able to pick up a new language in like a day or two. You're probably going to be like, "What, Matt? You're crazy. That's not going to happen," but it will. So it's really and part of the final assignment. Spoiler alert: the final part of the final project is to teach yourself something new in some way, some aspect. And you'll see that we've had plenty of people. People do a brand new language like Python or PHP. Some people do React Native. Some people just pick like a fun framework that they like or whatever. But you can totally do it. It's very easy to do, and we'll be here. We'll be here to sort of advise you. You can, during the final project time, that's where you'll do your research and be like, I'm noticing a lot of Python jobs in my specific area, or PHP jobs, and you'll send me a message and be like, Matt, we didn't cover these languages. What resources do you have to learn this new thing? And I'll be like, here you go, enjoy. And then you'll go and learn it, and you'll be ready for the job. Believe it or not, you can totally pull it off. So that's my take on this, is to do your research, and ask Nicole too. She'll help you out. She might have some insights. Maybe you're in a specific area that we've had other people in the past, and she might just know off the top of her head, or at least she'll have some resources to help you out. So it's sort of a more nebulous answer, but I think go with that. I don't know.
Yeah, I mean, just looking at the survey, right? Most popular is so JavaScript is probably the most popular, right? HTML, CSS second in popularity. If we go down here, the web frameworks are things like jQuery, which you're learning. React is something you'll also learn. Angular is something you'll also learn. So you'll be positioned at least to discuss web frameworks, right? Here's Express right here, right, is also being used. If you go to like other frameworks and libraries, Node is 49%.
Oh, look at that. That's cool.
It's almost half of the market right there.
Yeah, that's great. That's awesome.
So I would do what Matt's suggesting. You take a look at the technologies that are out there. Like for your final project, consider start companies that you might want to work for and see the technologies they use. So if you're like, I love this virtual reality stuff or augmented reality, which is on the rise. At LinkedIn, I'm always seeing these posts of people showing the next generation, and it blows my mind to think where we're headed in the next 10, 20 years for augmented reality. You learn augmented reality or one of the technologies that could get you in the door. And they're like, yeah, this person knows it. And these other graduates from GA, because we didn't teach it, this is the only person who knows it, and they have this background in web development. They seem like a solid fit for it. Okay, so find what you're looking for. Look here, maybe look at these technologies and see what's there. What's the most loved technologies out there? Things like that. I was tempted to learn Python. We have so many data science classes here at GA. I was looking to learn Python to teach data science. So I decided not to because there's so much other stuff I need to learn, and just to go in a different direction in web development was just not the investment I wanted to make. So I decided not to pursue it. But yeah, if you're into blockchain, look, blockchain in the real world, and like how are they using? Not at all. And you go into the blockchain and like look at what technologies they're using for that. Like I don't know much about blockchain. Sweet. Start thinking. Where's the future? All right.
Got another question real quick.
Sure. Yeah.
Because I think something Nicole said in Outcomes that kind of threw, I don't know about everybody else, but I know it threw me. Is it our portfolio sites? Is that something that we're actually like doing on our own, like just for our own selves, or is that something that's going to be like one of our projects?
Hey Matt, you want to take that?
Yeah, that's it's part of it's one thing that we add to the final project. I mean, it's something you can sort of it's very easy. You'll see by the end of the course you'll put one together in like a half hour or an hour.
I just wasn't sure because I was like the way Nicole at one time she said it was going to be and then it wasn't, and like I just got confused with the way it was worded. So I was like, is it or not?
Yeah, so I don't want to talk for Nicole because she might have her own set of expectations. I would ask her to make sure. But I just know that we usually say like, okay, you got to have a, portfolio site up by the time you graduate.
Yeah. So start thinking just maybe the design now. Considering you're going to learn a lot of technologies, start working through what you want this thing to look like. Maybe the front end, like the HTML, the CSS, how would you want to construct that? How would you want to make it look responsive? And then when you get to like fully blown out Node and Express, you could implement it through templates. When you get to Rails, you could do it via that as also, and along with React. Maybe don't hard code yourself into a corner in one tool when if you just build out the front end and made it look beautiful, you can convert that into templates at any point in time. So just consider that. There's no rush to get it done. So I would suggest planning now, adding functionality, look at other portfolio pages, see what you want yours to look like. All right, let's do this because we went way past that hour mark. Why don't we take a break? It's 11:13. Why don't we come back at 11:30, 11:15, right? 23, 25, 11:25. And then we're gonna do stand-ups. Come back, break time.